Example number 6 says a reservoir contains approximately this many liters of water at time t, where t is the time in hours for when the gates of the reservoir are opened. How many liters per hour are leaving the reservoir after 1 hour? So this is our function right here. And what we need to do, let's just call this function, I'm going to say, let me erase this contains, so I don't have room here. But let's just call it, since we're looking at liters of water, let's just call it L as a function of t. So the amount of liters as a function of time is equal to this. So now what we want is how many liters per hour are leaving, or what is the rate of change of liters with respect to time when time is equal to 1. Or another way of saying that is, what is L prime at 1? So to do that, find L prime. Now first, well, I should know this, when we take the derivative of this with respect to t, okay, this guy goes away because it's constant. This guy becomes negative 10 to the fourth, right? Because this is a constant right here. So the variable's right here. Okay, so even though there's an exponent here, don't think about that. You just have to think about this as a number. And so then this is minus 2 times 80, or minus 160 t, minus 30 t squared plus 25 t to the fourth. And now what we need to do is I should just call this L prime at t. Okay, so L prime at 1 is when we stick 1 in there. So we'll get negative 10 to the fourth minus 160 minus 30 plus 25. So this right here is negative, let's see here, I've got to have 4 zeros. Give me 1 second to think about this. Yeah, I need to have one more zero, so I've got negative 10,000 minus 160 minus 30 plus 25. Okay, so this is equal to negative 1, 0. Let's see here, 165, because the negative and this give me just a negative 5. So I'll have this. So my final answer is that there are 10,165 liters per hour leaving the reservoir. So that's where we get this is our negative rate of change.